Assalamualaikum, my name is Muhammad Firdaus bin Rashidi and my metric number is 20244093444.
Assalamualaikum, my name is Muhammad Ana Hazkil bin Muhammad Razi and my metric number is 20244443422.
Hello, my name is Irfan Hazi bin Muhammad Syafur Nizak. My metric number is 20244352338.
My name is Muhammad Syatirul Hasif bin Muhammad Sabri. My metric number is 2024235644.
We are from KCDCS 1102B.
Alright, let's start by answering the first question. What is differentiation and what are the techniques of differentiation? First, what is differentiation? Differentiation is a method of finding the derivative of a function. In simple words, it tells us how a function changes, how fast something is increasing or decreasing. Now, we move on to derivative. What is a derivative? A derivative represents the slope or gradient of a curve at a certain point. You can think of it like this. Secant is a straight line that cuts through 2 points on the curve. The tangent, on the other hand, is a line that just touches the curve at one point. The gradient of that tangent line gives us the derivative at that exact point. So in short, differentiation helps us find the gradient or slope of a curve at any point, and the result we get, the derivative, tells us how steep the graph is at that location. So next, let's begin with the power rule. This rule is used when we have a variable raised to a power. What do? I multiply the exponent by the variable, then I subtract 1 from the exponent. Why does it make sense? Because it reflects how steeply the function is changing at each point. Moving on to the constant rule. This one is simple. When the function is just a number, the derivative is 0. Why? Because the constant doesn't vary, so its rate of change is 0. Next, the constant multiple rule. If a constant is multiplied with a function, we can pull the constant out and differentiate the function. Why does this work? Because multiplying by a constant just kills the rate of change. Now let's talk about the sum and difference rule. When two or more functions are added or subtracted, we simply differentiate each one on its own. It works because differentiation is a linear operation. The product rule. When two functions are multiplied together, we can just differentiate each separately. What we do instead is follow the formula u prime v plus uv prime. It works because both functions are changing and we need to account for both change. Following that is the quotient rule, used when one function is divided by another. We apply the formula why it works because it adjusts for how both numerator and denominator vary. Let's go to the chain rule. This one is used when you have a function inside another function, like a function sandwich. You first differentiate the outer layer, then multiply it by the derivative of the inner function. It works because change flows from the outside through the inside. Sometimes we can solve y explicitly. That is when we implicitly differentiate. We differentiate both sides normally, but treat y as a function of x. The trick is to remember that whenever we differentiate y, we attach dy dx. And finally, logarithm differentiation. This method is useful when we are dealing with a variable in both the base and exponent or complicated expression. We start by taking the natural log of both sides to simplify, then differentiate. Why it is useful? Because log breaks down multiplication, division, and power into simple parts.
Now we on question 2. The question is fx equal to cos 2x plus 5 ln 3x. Then we use a product rule, which is u equal to cos 2x plus 5, and differentiate, we got a u prime equal to negative sin 2x plus 5, and v equal to ln 3x, and differentiate it, we got a v prime equal to 1 over x. And the formula is u multiply v prime plus v multiply u prime. Then we fetch the answers and fill to the formula, which is cos 2x plus 5 multiply 1 over x plus ln 3x multiply negative sin 2x plus 5. So the final answer is cos 2x plus 5 over x plus negative sin 2x plus 5 ln 3x. Now we move to question D, which is fx equal to e. Question D is fx equal to exponent power of 3x subtract 1 over 4x plus 3. Okay, first step 1, identify the two functions by using quotient rule. So we got the u is equal to exponent 3x minus 1 and v equal to 4x plus 3. And we move to the next step, differentiate u and v. So we got the u prime equal to exponent powered by 3x minus 1 multiplied by 3. So we got the exponent powered by 3x and v prime equal to 4x plus 3 equal to 4. The final step, which is step 3, is apply the equation rule. The formula is f prime x equal to e multiply u prime minus u multiply v prime over v squared. Okay, and then fill the formula which our previous answers, and we got the final answer is equal to 12x exponent powered by 3x plus 5 exponent powered by 3x plus 4 over 4x plus 3.
Now we go to question 3. Given 5y plus 3 in bracket power of 4 plus sine in bracket xy equal ln in bracket 2x minus 1. Find dy over dx using implicit differentiation. For the first step, we will apply the derivative operator to both sides, which means it will be d over dx multiplied by 5y plus 3 in bracket power of 4 plus sine in bracket xy equal to d over dx multiplied by ln in bracket 2x minus 1. Okay, for the second step, we will differentiate each part one by one. Okay, for the first one is d over dx multiply 5y plus 3 in bracket power of 4. In this case, we will use chain rule and we will simplify and we will get 20 multiply 5y plus 3 in bracket power of 3 multiply dy over dx. Okay, for the second one is d over dx sine in bracket xy. We will use chain rule again. Since xy is a product, we use the product rule inside. As you can see, we will simplify and we will get x multiplied by cos in bracket xy multiply dy over dx plus y multiply cos in bracket xy. And the last one is ln in bracket 2x minus 1. We will differentiate ln and we will get final is 2 over 2x minus 1. Okay, for the step 3, we will collect all terms that we will differentiate earlier. And then we will get 20 multiply 5y plus 3 in bracket power of 3 multiplied by dy over dx plus x multiply cos in bracket xy multiply dy over dx plus y multiply cos in bracket xy equal to 2 over 2x minus 1. After that, we will move y multiply cos in bracket xy to the right side to isolate dy over dx on one side only. And after that, we will group dy over dx. And it will be dy over dx multiplied by 20 multiply 5y plus 3 in bracket power of 3 plus x multiply cos in bracket xy equal to 2 over 2x minus 1 minus y multiply cos in bracket xy. For the last step, we will solve for dy over dx, which means it will be dy over dx equal to 2 over 2x minus 1 minus y multiply cos in bracket xy over 20 multiply 5y plus 3 in bracket power of 3 plus x multiply cos in bracket xy.
Question 4. Use linear approximation to estimate the value of 2 square root of 8.99 minus 3 times 8.99 correct to 3 decimal places. Okay, we go for step 1. We need to set up function fx, which is fx equals to 2 set x minus 3x, fx equal to 2x the power of 1 over 2 minus 3x, and the first derivative is f prime x equals to 1 over set x minus 3. We go to step 2, which is we should find the dx. Okay, for this step, we should know what is x and x naught, where x is a latest value or given value, and x naught is an initial value or estimate value. So, how we can find the dx? We can find the dx by x minus x naught. So, we will get 8.99 minus 9, and the answer is negative 0.01. Step 3. We need to substitute into the formula, and as we can see, the formula is fx equals to fx naught plus f prime x naught dx. So for this formula, we need to replace our fx function equation and f prime x equation into the formula, which is our fx equation is 2 set x minus 3x, and the f prime x formula is 1 over set x minus 3, and we need to substitute the value of x naught. So we will get f in bracket 8.99, which is the value of x equals to 2 square root of 9 minus 3 times 9, which is the equation of fx, plus in bracket 1 over square root of 9 minus 3 n times negative 0.01, which is the equation of f prime x. So we will get negative 21 plus 2 over 75, and the final answer is negative 20.973.
Cerita kedai kopi, cerita kedai kopi.